the graphs of log functions. So remember the reflection line that we're going to use for log functions is y equals to x, which is diagonally across the graph. We'll take a look at that in a second. But part of graphing also is knowing that we have A, which shifts it, stretches and compresses it. It'll also flip it if A is negative. We have our friend H here, which moves it horizontally, okay, across the x-axis. You take the opposite. So remember, H is sneaky. It goes opposite K, kicks it up, kicks it down. So that rises it up and drops it down lower. All right, so when we're graphing the log, it's the inverse of the exponential. Remember, the exponential, our asymptote was on the x-axis or along the horizontal, depending on what K is. In this case, it's going to be on the vertical when we do the log. So we'll go up and down the y-axis. Okay, so first thing we want to make sure is that we can find A, H, and K. So let's look at this example. A is going to be equal to 1. H is going to be equal to 3. And then our K is equal to 4. And that tells us our transformations. No stretch or compress. No flip, because A is 1. H is 3, so that means I'm moving to the right 3 spaces. And with K being 4, it means I'm going to go up 4 spaces. So that would be our transformation. So we're going to graph what is considered to be the parent function. Okay. So one of the things you notice is that we don't have a base here. When we don't have a base written, the base is going to be 10. So this is going to be base 10. Now, to actually demonstrate this, and we'll come back and fill in our domain and range and all that, we're going to use, or I'm going to use, the Desmos graphing calculator to help us out with this. Okay, so if you look at this, let's go ahead and put our line in for our line of reflection. And then we've done the exponential. So y is equal to 10x. Notice we have that point. We talked about that critical point right there at 0, 1. And then we said there's something close to, is this going to be 3? All right, 2.5. So, but this one's base 10, so it goes way up there, right? So it's way up high. Okay. And then it comes down and never touches, even though it looks like it's on that x-axis, it never touches that x-axis. So we don't have a whole bunch of points to select from. If we're looking at a graph of this, we really only have this point. And you're just going to have to kind of mirror the image here. Notice here it's going away, so we have to go away from the XY like that, and then we have to come along, and we're going to go along the y-axis because the y-axis is our asymptote. Just like the x-axis is here, if we're doing a log, the inverse, swap your x and y. So that means this is going to look like the asymptote here. So the log of base 10, this is base 10 of x, looks like that. And there is the inverse. So the green line is the inverse. So we can look at some of this behavior. As we go off to the right, we're going up to infinity. Right? As we go left, we're going down to negative infinity. Right? Or excuse me, as we go left, yeah, it's going down to negative infinity. All right. I think of some of the other things that were on there. We can find the x-intercept. We know that's at 0, 1. Okay, there isn't a y-intercept. So let's go back and fill out that little chart that was on that. We could throw a quick sketch on here. So let me grab the red and put in what could be considered or asymptote. A little crooked there, but that's okay. We all know that's on the x-axis. Okay, let's grab blue for our graph, right? So we know we're usually at 0, 1. Now we're going to be at 1, 0. And this has to go along here really close. We don't want to cross. Come up through that point and then kind of go off on a nice curve like that. And we have arrows on the end. Okay, so VA, our vertical asymptote, right? So if it is vertical, it's going to be x equals 0 in this case. As x goes to, let's go to the, we'll go to the right first. As x goes to infinity, f of x is going to infinity. Now, as we come left, what are we approaching? We're not approaching infinity. That's way out there. We can't go past this line, which is at 0. Okay. This goes to negative infinity. Goes to negative infinity. So our domain is restricted. Domain is restricted. It's going to go from 0, really close to 0, so it's not squared off, and then we're going to infinity. And in this case, the range is going from negative infinity and up to infinity very slow. So we're going to say it is all real for that range. Do those on a calculator. Okay, but this one, something like this, is we can definitely handle that because we understand what AHK are, right? So if we look at this one, we know A is 2, so I have a stretch of 2, and I have a shift to the left of 3. Okay, so if I have a shift of a left to 3, that means that I'm going to have an asymptote that is going to be, I want my line tool here. My asymptote is going to be at negative 3. So there's my vertical asymptote. Alright, so let's go ahead and write that in there. So this is going to be x equal to negative 3. X is equal to negative 3. Okay, then we can look at, let's talk about what our behavior is here now. So usually we go through at 1, but we got a shift of 3. So 1, 2, 3. So that's going to put our graph right there. That's kind of the only really, well, we can get this point. Remember I said if we're close to 3 away from this point, 3 away, we can put our point very close to, that's the only point we really need. So let's just go ahead and put this in here. It goes off something like that. Okay. So we'll take that sketch. Alright, so you can see as we approach negative 3, f of x is going towards negative infinity. As x goes out towards infinity, we're going off up to infinity. The domain is going to go from negative 3 to infinity. The range is going to be all real. The var r for our range. Okay, well, look at this function, and we have to figure out what AHK is. So A is equal to negative 1. Come on, give me a 1 there. Okay, A is equal to negative 1. H is 0. And we know K is equal to negative 4. So we're going to shift down 4. And our asymptote is going to be on the y-axis. So let me just go ahead and quickly get an asymptote in here. Go ahead and get the asymptote in place here. So I'm just going to go ahead and put my dashed line in place. And it's going to be there on the axis. Okay. So let's see. Also looking at this, we have a shift down of 4. So remember, this point is usually a good point at 1, 0. So we're going to have to shift it down to here at 1, negative 4. So that's my shift down. And then we know it's upside down, so it's going to start up here, and we're going to come down. And I didn't change this to a solid line and come around. Oh, okay. Need a little bit straighter sketch, but that's what it looks like. So now I can start filling in my values up here. My vertical asymptote my vertical asymptote is x equal to 0. Okay, as x goes to 0, this f of x goes to infinity. As x goes to infinity, my f of x is going down to negative infinity. Domain on this, well, domain, so that asymptote 0 to infinity, and then the range is everything, double bar r. Alright, so just knowing our AHs and Ks, we can kind of look at our end behaviors, our vertical asymptote, and domain and range. So this is a log function, and we have a shift to the right 4 spaces. Alright, and we have a shift up of 5. So our vertical asymptote is going to do a shift over to 4. So x is going to equal to 4. And as we approach 4, this one is positive, so it's going to do our curve up, right? So it's going to go, actually, it's going to go 4, and it's going to go down to negative infinity. And as we go out to infinity, it's going to go to infinity. Okay, so our domain on this one, our domain is our x values. That's going to start at 4, close to 4, and go to infinity. Now the range, just because we shift it up doesn't mean it doesn't go all the way down, which it does. We know it does. It goes from negative infinity to infinity, so the range is everything, double bar r. Make sure we close that. And we kind of get that sketch and that graph in there.